So guys, next we will going to discuss L3 routing configuration. So what will router A do if it receives a packet which is destined for router E? So we have on the right hand side you can see the topology which has 5 nodes. These 5 nodes represents L3 routers and which are interconnected with each other through links. So let us consider a scenario when the router A receives a packet which is destined for remote router E. So what will router A do when it receives a packet that is destined for router E? Will router A forwards the packet either to B or to C? How will router A know that if it receives a packet that is destined for router E, it has to forward to either B or C? How router A will take this decision? So how A would know that in order to forward the data to destination, it is E, it has to forward the packet to B or C, which will be the better path. So in order to accomplish this, we need to feed rules in every L3 router in the network. Note the word in every L3 router in the network, which defines the behavior of a L3 router to how to forward the packet destined to remote destinations. These set of rules are called L3 routing information. So let us take an example. Without L3 routing information, routers which are one hop away cannot talk to each other. That is, if you do not feed this L3 routing information, router A cannot talk to router D. And router A cannot talk to router E because both D and E are more than one hop away from router A. Whereas the machines which are directly connected can always talk to each other via L2 routing. There is no need for L3 routing. So this is the reason that directly connected machines can always talk to each other without feeding these L3 rules. So it will be more clear to you when we will be learning in detail the L2 routing and L3 routing. But for now, our purpose or our aim is to understand what is L3 routing information. So we will understand this by taking a very simple example. Suppose the router A receives a packet which is destined for remote destination E. So the destination is E. Now let us say that we have fed rules in all the routers in the topology stating how to forward the packet, stating that when a router receives a packet which is destined for remote destination E, what will router is supposed to do? So the diagram shows that this is L3 routing information that is installed on each router in the topology. This information carries two parts. One is the ultimate destination to which the packet is eventually destined for, and the next piece of information is the next hop. That is the next immediate node in the topology to which the current router should forward the packet so that packet eventually reach its intended destination. So when A receives a packet which is destined for router E, A knows that it has to forward the packet to the next hop which is router B. So the packet goes to the router B. Router B will look up its L3 routing information and will know that in order to send the packet to its remote destination E, it has to forward the packet to the next hop D. And D again does the same thing, that is, D will forward the packet to E according to its L3 routing information, and the packet eventually reaches its intended destination. So you can see that these pieces of blocks or L3 routing information which have been fed on every router in the topology, so that all these routers work together to take the packet along the journey so that packet reaches its intended destination, that is the router E. So this is called L3 routing information. Now, next we need to understand that what exactly is L3 routing information mean. In this topology, you can see that there is a router A and there is a router B. Note that router A and router B can be present anywhere in the world. They are not directly connected routers, right? Now, how many local subnet does the router B have? It has 6 local subnets. Corresponding to each interface of the router B, there exists one local subnet. So, total number of local subnet that the router B has is 6. You can easily calculate by applying the mask value on the IP address on each interface. So in this diagram, the router B has 6 local subnets. Now, having said that, whenever we say that the router or machine B is reachable from another router or machine A, it simply means that A has the routing information to reach at least one local subnet of B. Note the word at least. As long as A knows how to reach at least one local subnet of router B, we can say that A can reach B or B is reachable from A. So it's all about reachability of subnets and not particularly machines. So A can reach B as long as A knows the next hop information to reach destination D, where D is any local subnet of B. L3 routing is not about how to reach a particular machine. It's about how to reach a particular subnet, right? So it's wrong when I say that B is reachable from A. More precisely, we should say that one of the local subnet of B is reachable from A. As long as one of the local subnet of B is reachable from A can always send a packet to the router B, right? So this is all about what is L3 routing information means. Now going forward, again, L3 routing is not about how to reach a particular machine, but it's all about how to reach a particular subnet, because every machine in the topology has n number of local subnets. Now, in our 3-node topology, you can see that if VM2 wants to talk to VM, that is, this is VM2, and if it wants to talk to VM, then VM2 should know how to reach at least one VM's local subnet. Now in our topology, how many local subnet does the router VM has? It has only one local subnet, which is 192.168.4.0/24. Let's call it as local subnet B, right? So if the router VM2 wants to communicate with the router VM, VM2 should know how to reach the local subnet B. And note that the subnet B is a remote subnet for router VM2. So this is same as if your uncle wants to visit to your house. He should know at least one path to your house, right? So if VM2 wants to talk to VM, you should read it as if VM2 wants to reach one of the local subnet of VM. Then VM2 has to be configured with L3 routing info, which tell VM2 how to reach VM. That is, it's one of the local subnet, because VM and VM2 are in different subnets, right? So we need to configure VM2 machine with the L3 routing information, which will tell VM2 that whenever it receives a packet which is destined for router VM, then VM2 would know that where it has to forward the packet. So same applies for if VM wants to talk to VM2, right? Because again, VM and VM2 are more than one hop away, and therefore VM and VM2 can talk to each other only when they are equipped with L3 routing information, which will tell them how to reach each other. So going forward, VM1 shares a local subnet with VM2 and VM. This is a correction, it's a VM. Right? To elaborate this point, VM1 has a local subnet A. So note that the subnet A is a local subnet of VM1 as well as VM2, and the subnet B is a local subnet of VM1 and VM. So in this topology, VM1 has a local subnet A which is shared by VM2, and VM1 has a local subnet B which is shared with VM. Therefore, VM1 can talk to VM as well as VM2 without any L3 routing information, because both the routers, that is VM and VM2, are directly connected routers to VM1. And both the routers falls in the local subnet of router VM1. Therefore, VM1 can reach to VM2 and VM2 can reach to VM1 without any explicit L3 routing configuration. Similarly, VM1 can talk to VM and VM can talk to VM1 without any L3 routing configuration configured on router VM1 or VM. The reason simply means that VM1 shares a local subnet with both the routers, that is VM2 and VM. VM can talk with VM1 but not with VM2 unless L3 route to VM2 is configured on VM. And reason being simple, because VM and VM2 are in remote subnets. They do not have any common local subnet, and therefore VM needs L3 routing information to reach VM2. VM2 can talk only with VM1 but not with VM unless L3 route to VM is configured on VM2. So that is same reason. So thus machines are to be configured with L3 routing information to enable them talk with other machines which are present in remote subnets. Remote subnets means the machines which are more than one hop away. So in our topology, you can see that the router VM2 is 2 hop away from router VM, and the router VM is again 2 hop away from router VM2. So L3 routing simply says that to reach a remote subnet X, next hop is Y. So let us understand the semantics of L3 routing in the next slide. So another point to note that L3 route dictates how to reach remote subnets and not how to reach remote machines. Remote subnets implicitly means remote machines. So you will understand this point better when we will be discussing the L3 routing in detail. So L3 routing dictates how to reach remote subnets and not remote machines. And the last point is L3 routing configuration is not required to reach local subnets. So that I have already illustrated that on router VM, you don't have to configure any L3 routing information to reach router VM1 because both shares a local subnet B. So if VM wants to talk to VM1, this talking is done or supported by L2 routing only. So whenever a machine wants to communicate with another machine and both the machines are present in the same subnet, only L2 routing is required to carry out this communication. Right? So in this example, router VM and the router VM1 are in the same local subnet, which is subnet B, and therefore VM can always ping the IP address 192.168.4.1, and VM1 can always ping the IP address 192.168.4.2, and this ping will be supported by L2 routing only. So there is no L3 routing taking place in this scenario when the communicating machines are VM and VM1 or VM1 and VM2. So you will understand this concept better when we will be learning L2 routing in detail in the module 4.